Welcome Algebra 2 students to our second part of section 7.5. Today we're looking at operations with radical expressions. Continued. Operations with radicals. When you add expressions containing radicals, you can add only like terms or like radical expressions. So the idea of like terms applies to, in this context now, like radical expressions as well. Two radical expressions are called like radical expressions if both the indices and the radicands are alike. Now the term indices is actually a little bit new to us. It speaks to the plural form of index, which is essentially just another word simply for root. Okay, so if I'm asking you guys to take for example, the cube root of a, all right, some random or arbitrary radicand. The index or root is that, and that is the radicand. Okay, so if I ask for the index again is just the root. Indices meaning the plural version, I guess, really, of index. To multiply radicals, use the product and quotient properties. For products of the form a times root b plus c times root d times, and then e root f plus g root h, use the FOIL method. So we're definitely going to do some of that today. To rationalize denominators, use conjugates. Conjugates is not new to us as well. Numbers of the form a root b plus c root d and a root b minus c root d. These are going to be very important to highlight, so let's do that. Where a, b, and c, as well as d, are rational numbers, are called conjugates. The product of conjugates is always a rational number, which is pretty powerful. Let's continue. Example 1. Simplify 2 root 50 plus 4 root 500 minus 6 root 125. So 2 root 50, that simply becomes 2 root 5 squared times 2, because again, that's what, 25 times 2. So they're not using factor trees, but the product property is pretty nice here in that you can still see we've got a perfect square here. We're left with a number under the root. We could pull out the square root of 25 as 5, so you'll do 2 times 5, which is 10 in the next step, or 2. 2, like I said, stays under the root. 500, well that number we can write as 100 times 5, or as you see here, 10 squared times 5. The square root of 10 squared is 10. 10 times 4 in the next step will give us 40. Root 5, well, we'll see that as just what we were left over with. In the next particular root, well, we've got 125, 5 squared times, or 25 times 5 is 125. The square root of 25 is 5, 6 times 5, and really it will be a negative, so negative 30 in the next step, or 2. The root 5 stays underneath the root. So again, 2 times 5, that's 10, 10 root 2. 4 times 10, 40, so 40 root 5. Negative 6 times 5, negative 30, so negative 30 root 5. Now what happens here, which is very important, if we look at this radicand and index of 2, this radicand and index of 2, turns out these are quote-unquote like radicals. So we're going to combine like radicals, and here's how. The coefficients, I'll call them kind of like 40x minus 30x. You're simply just going to take 40 minus 30, and of course that's 10. The root 5 and root 5, well, that's kind of like saying 40x minus 30x. So if we did 40x minus 30x in a different context, of course you would say 10x. So the root just stays as is, and the final answer, 10 root 2 is not a like radical to the other, so the final is 10 root 2 plus 10 root 5. Moving on, example 2. Simplify 2 root 3 minus 4 root 2, that quantity times root 3 plus 2 root 2. So they'll FOIL here, and they show that with 2 root 3 times root 3. So first, outside 2 root 3 times 2 root 2, inside negative 4 root 2 times root 3, and then the last, negative 4 root 2 times 2 root 2. 2 root 3 times root 3, that's 2 root 9. Square root of 9 is 3. 3 times 2 is 6. 2 root 3 times 2 root 2, 2 times 2, that's 4. But you still have the root, what, 3 times 2, so root 6, so 4 root 6. Negative 4 times root 2, root 3, or root 6, so negative 4 root 6. And then negative 4 times 2, that's negative 8, but you still have got root 2 times root 2, or root 4, which is 2. So you got negative 8 times 2 negative 16. We do have some things to combine right here because this and this happen to be like radicals, same index of 2, square root in other words, as well as the radicands being the same. That's 6 and that's 6. So we can easily see here, well, 4 minus 4, that's quite nice. That's just 0. It's like saying 4x minus 4x. All right, so that's, of course, 0. So those just cancel. And then last, 6 minus 16, that's negative 10, and that's your final answer. Example 3. Simplify 2 minus root 5 all over 3 plus root 5. So in this particular problem, what they're going to go ahead and do is rationalize. We can never leave a root in any denominator of any fraction. So because that's the case, I'll put a question mark here as to kind of what we're going to do now. We're going to go ahead and consider multiplying, just like we did in the prior section, using kind of the root again, or at least trying to get a perfect whatever in the square root as we multiplied. It's not technically the same type of thing exactly, but it's similar in the sense that we're going to now multiply numerator and denominator by something to undo that root. In this case, it's called the conjugate. Okay, so the conjugate, as you can see, basically, well, if you look at the original denominator, 3 plus root 5, the conjugate of 3 plus root 5 is 3 minus root 5. Something very, very nice is about to happen when you multiply just the denominators there. Now I'll go ahead and put parentheses around the numerator as well. But the denominator in particular, the denominator, if you FOIL 3 times 3, that's 9. Okay, now they wrote 3 squared, which is fine. Outside will be 3 times negative root 5, so negative 3 root 5, which I'm going to write down here. And then inside will be positive 3 root 5. What happens is, quite nicely, and it always happens, when you add outside and inside, they cancel. So all you really have to do technically is first and last. If you do now last, root 5 times negative root 5, again in our last step of FOILing, you get negative root 5 squared, or, gosh, root 5 squared is just going to be 5. So really then it becomes 3 squared, 9, and then again minus 5 there, so 9 minus 5 is 4. And the numerator, you also need to FOIL. So 2 times 3, that's 6. 2 times negative root 5, and then 3 times negative root 5, that's negative 2 and negative 3, or negative 5 root 5. And then last, you'll do negative root 5 times negative root 5, and that ends up being positive root 25, which is just 5. From here, 6 plus 5, that's easy, that's 11. Don't forget about the minus 5 root 5. Still, again, the denominator, because it's now a single number as opposed to 3 plus root 5 from what we remember from the beginning. That is completely simplified. I don't have a root in the denominator, and we're good. Now this concludes the notes. I try to keep it short and sweet. What I do want all of you to do, in addition to obviously finishing watching this video, is I'd like you to maybe try out some of the problems on page 32 kind of on your own. It's a recommendation. So I'm going to recommend numbers, let's say 1 through 11 odd. In class tomorrow, we will actually be finishing all remaining problems. This should conclude section 7.5, and again, tomorrow will be a nice kind of recap of everything we've been doing in this section. Take care.